Welcome everybody. Good afternoon from the UK. Hello to the rest of the world, and we're just about to kick off our webinar on public transit complemented. So hopefully everybody can hear this. If you've got any problems, drop us a note in the chat box and hopefully we can sort it out. But you should be able to see me, the title slide, and also hear me now. So off we go. Just like to run through the agenda to begin with and introduce our speakers. So my name's David Holcroft. I'm the chairman of ATRA Industry Group. I also consult on the same subject in terms of PRT. Our agenda today is a little introduction by myself about what ATRA, the Advanced Transit Association, is. Then I'll be handing over to Peter to talk about automated transit networks, then on to automated transit system applications, then the business case, and then question and answers. You can also post questions in the chat section during the webinar, and the presenters who are presenting at the time will attempt to answer those questions. I'll also round up a few of the interesting ones, and we can perhaps discuss those in a little more detail at the end of the session. So apart from myself, we also have Peter Miller, who's president of PRT Consulting and based in the US, Robert Lohman, commercial director of To Get There, a PRT supplier based in the Netherlands, and Richard Isles from the UK, who's the business analyst from ULTra Global. So those are our speakers for today. First, I'd like to tell you a bit about the Advanced Transit Association. Our vision is the worldwide use of advanced personal transit systems that benefits people, businesses, and the planet. Our mission is to advocate for the development and deployment of these advanced personal transit systems, and we aim to be unbiased, collaborative, professional, and relevant. We're a not-for-profit organisation, and we have both an academic council aimed at promoting PRT and advanced transit systems in the academic world, and an industry group which is collective of suppliers and consultants. If you're interested in becoming a member, there's a web address on the slide there, but also if you go to our website, you'll see the details there. In terms of the members of the industry group, you can see these at the top of the page. Arup, Lee Elliott, To Get There, Berger AMAM, Logistic Centrum, Padaris, ULTra, PRT Consulting, and the University of Bologna. The industry group is a little more focused on providing professional and unbiased advice for those people who are interested in PRT and GRT systems. So it's slightly more focused than the Advanced Transit main body. What we engage in, apart from webinars like today, is up-to-date Advanced Transit news, which is regularly posted on our website. So if you would like to visit that, you can see how things are going. We publish a Transit Pulse newsletter periodically, which also provides similar news. We aim to be objective in everything that we put forward. So apart from news, we also put various information, help and documentation on the site that can be of use. We frequently have a physical presence at conferences where we're providing information. The next one, I believe, will be Podcast City, which is in Stockholm in September. We undertake joint presentations with other organisations where appropriate, as I say, organise webinars and organise and support events, conferences of our own, for instance. So now I'd like to hand over to Peter Miller, who will take you through an introduction to automated networks. Thank you.
Thank you, David. So I'm going to talk about automated transit networks that we also sometimes call personal rapid transit, or PRT, also sometimes known as smart cars. So there are a number of different terminologies for what's essentially the same type of systems. So mobility is something that we all need, but travel is unique. People need to go where they want to go, when they want to go, and typically don't share the origin, the destination, and the trip time, which is the reason why on large train systems and things like that, we need large stations where people can gather who are going to similar directions and can wait together for the trip time when they can all travel together. So people look for the most economical way to make that trip, and one of the things that ATN and PRT tries to do is to provide that unique origin to destination trip at the time people need it. And so also what PRT attempts to do is to help provide both high capacity and lower capacity connections. This is an animation showing ATN or PRT on the left, and transit on the right. As you can see, people enter on the left and on the right at the same time. On the left, they're typically met by a vehicle. They select the destination, and off it goes to the station of their choice. On the right, they collect on the platform and have to wait. So you'll notice the platform on the right is considerably bigger than the platform on the left. And the guideway is wider too. Now, sometimes people arrive at the platform and there's no vehicle waiting for them. Typically on ATM, this wait is less than a minute. You notice that vehicles not stopping at this station go on by. They don't have to stop here. They have a different destination, they go direct to their destination. Now, in addition to the station being offline, some systems have the ability for the individual station bays to be offline too. And so if something happens and somebody's delayed in a station bay for some reason, the whole system keeps operating around them. And there's no real delay to the system, there's just a slight loss in capacity at the station bay. For example, here, the person in the bottom vehicle doesn't press the door close button. The vehicle sits there, but the whole system keeps operating around him. This is not possible in all systems, but it is possible in some systems. Now, when the train finally arrives, it's multicolored because it has to stop at every station that somebody needs to get off at. One of the problems that we have with conventional transit is that there's a trade-off between the number of stations you have and the number of stops that you can make. If you have more stations, you have to make more stops, and the trip is less convenient. But if you have more stations, you also have better coverage, and more people are within walking distance. So with ATN, with the stops being offline, you can add stops, and the number of stations does not impact the journey time for people using the system. If we have a mass transit system with, let's say, 2 stations, ATN can serve as a feeder to these stations and expand their reach, so there becomes a larger area that can reach the station without having to drive there. These networks can be expanded until ultimately they're hooked together. So now we have a combined system where the shorter journeys can be made quickly with ATN, and the longer trips can be made quickly with mass transit. The advantage of this is that the mass transit stations can be further apart. This reduces the cost of the mass transit system. And at the same time, more people can have access to the system. So this helps solve the last mile problem. ATN can operate as a feeder transit system, helping expand the reach of the station. We found that typically the number of people prepared to walk to a station starts to drop off at about a quarter of a mile or half a kilometer. And so ATN can provide this service and expand the reach of regular transit systems. This is a study done in Sweden and is a good example of this. Here we have a train station represented by the black dot, and on the left we have bus access depicted, and on the right we have ATN access depicted. As you'll see on the left, the area within about a 30-minute bus time of the station is fairly small, whereas with a comprehensive ATN network, this area increases dramatically, and you find that almost the whole town is now within about 15 minutes ride of the train station. So with that, I'm now going to hand it over to Robert Lohman for his session.
Yes, hello. I think I've lost my screen at least. I'm not sure if you're experiencing the same problem. No, my screen at least is back. Technology, wonderful. So if we start looking at what are the ATN systems that are now in operation, what you see is that throughout the last 30 years, multiple of these systems have started their development, and there have been a couple that actually have come into operation. The biggest example of that is probably the Morgantown operation in West Virginia, where the system is now starting to be upgraded, but has already been operational for 30 years. There's been a flurry, or I'm not sure if you're allowed to call it a flurry, but relative to the years before, when it's been relatively quiet when it comes to automated transit networks, of systems realized over the last, well, let's say 5 years, 6 years. The Rivium system in the Netherlands, the Masdar operation in Abu Dhabi, the Heathrow system in London, and the new Sanchan system in South Korea. All the systems now are operational, and you'll see more data becoming available from these applications as we're going along. When you start looking at what type of applications are actually possible, there's different types of configurations that can be considered. The most traditional, perhaps, is the pinched loop configuration, where you're basically configuring it the same way as a normal APM or a bus line would be configured. So it's corridor bound, and it goes from A to B. It has multiple stops. ATN can elect whether they stop at all stations, or whether they skip stations, or whether they go directly to origin to destination. Another example is a loop. Basically, you're widening the catchment area because the stations are further apart, so the walking distances towards the stations actually become lower, so you're actually reaching out to more people with the system. The only disadvantage becomes when you finally reach a station is your vehicle might take the long way around, and if it takes the long way around, the problem is that your travel time becomes a little bit longer. The ultimate vision, of course, for ATN, Advanced Transit Networks, is what you see at the bottom. This is multiple loops interconnected with the ability of the vehicles to use any of the loops and basically reach any of the destinations. Therefore, we're trying to resemble the travel pattern that people also experience when they're using their bike or when they're walking or when they're using their car. All forms of mobility that allow you to get anywhere you want to go at any time, although for the car that's less and less the case nowadays. When you are looking into a new application and you're deciding on what the network should be, there are a couple of base decisions that need to be taken in how do you design such an application. And perhaps listing the obvious, we've put these out on the slide, because often enough what you see is that these ATN networks really move away from the traditional point of designing a transit system, and not necessarily designing for a new technology like this is the same way as designing for a traditional technology. What you see is a couple of pictures that were initially drawn for a city that we were working on, and you see that the spine of the network is actually going to the main locators or the main attractors in the system. Stations are spaced such that the walking distance is minimized, so you shouldn't end up with a situation that you could pick two stations that are located within a 100-meter walking radius, while somebody else might need to walk 300 meters. The complexity in the design in the end is meeting the architectural and the build-up environment with the need of people to be able to access the transportation system. And thankfully there's a lot of consultants worldwide that have ample experience with designing systems, and I think by now even vendors such as ULTra and ourselves have gained enough experience to be a good sparring partner for you or for your consultant at the time you are working on your design. To give you an example of where you can find these type of where you can imagine that advanced transport networks would be. What you see here is a schematic layout of a city with corridor transportation systems going from a central station to the suburbs of the city. You see a rail line going straight through the city, and you see 4 examples of advanced transit systems. And let's start from left to right. So on the left side, you have a simple line connection within a business park. This is much like the Rivium system, where we connect to a subway station. You could look at a residential suburb. The new suburbs that are being built that are more rural typically are less accessible to public transportation, while the main systems are often relatively close to those suburbs. So generating an internal feeder system to those external systems actually provides those new neighborhoods with excellent public transportation access. In the city center, and this is of course the ultimate vision for advanced transit networks, a network of loops within the city center, so that whenever you get to the station, you can also get to your final destination. Very rarely the station is actually the final destination of a traveler. And on the bottom right, you see a loop system, a network system in a business or industrial park. Show you a little bit more about those different application areas. Airports are a typical example of automated people mover systems. And what you see here is a typical airport with 2 terminals and some facilities close to the terminal. Of course, the airport has to have a link towards downtown. Usually downtown is so far away that we're not looking at automated transit networks to connect to downtown. We'll be looking at different types of systems, so metros or light rails or those kind of systems. When it comes to ATN, there are several flows that you can actually accommodate with these type of systems, whether it be an airside link of the 2 terminals or a landside link of the 2 terminals. Very different in nature, but both are realizable with ATN. At the same time, on the land side, instead of having a line configured system with larger units that stop at every station, you could also consider laying out a small PRT network with multiple stations all being interconnected. And the good thing about such a PRT network is that in time you can phase it and you can expand it to also reach other destinations within the network. And when you really look ahead, it's even possible to say, why not combine the two? So both a line haul system and a PRT system are combined, preferably using the same infrastructure. In this way, you can serve the different needs that there are for travelers within the system. Another very feasible application is campuses, and I put the definition for campus in here just to be certain. We're not only talking about the school, we're talking about large hospitals, or we're talking about companies like Google or Apple or Microsoft have their own company grounds. And what's usually very important, whether it's a university or whether it's a school, is the interconnectivity between the different buildings. If you imagine multiple companies being in the same area, it could very well be that it stimulates the companies and the learning within the companies that their employees are able to commute to each other real easily. Conversations we had, especially in the Middle East, about these kind of systems are that when it gets to summer and becomes really hot, that people need to move from one building to the other, they actually grab their car and they start driving around looking for a new parking space closer to the building where they need to be. This is the type of movement and the type of pollution that you can actually easily take off the road by making sure that the internal transportation is well facilitated. Another example is business parks. And what you see here is an example of a business park where each company in the business park has given up their own parking. When every company has its parking, the parking will be sized to accommodate their peak demand, which means that every parking lot is a little bit oversized for the needs of the companies. So if you consolidate all the parkings on the outskirts of the business park, you're actually saving space, allowing the companies to use more space for the actual office rooms, or to create those parkings into green spaces and therefore create a much more agreeable working climate for the people that are employed by the companies. Obviously, urban developments and eco-cities are a trend, and with PRT, it fits those trends really well. It means that you would have no more parking on street, you would have no more need for streets in the development itself, and all the carbon emissions from the cars at the site would be, well, kept outside of the city limits. We see the eco-cities and the car-free city centers, or the car-reduced access city suburbs becoming more and more normal in very much in European countries. And with that, I'll hand over to Richard on behalf of ULTra Global to present the business case of PRT and ATN systems to you. Richard, the floor is yours.
Well, good morning, good afternoon, good evening to everyone. Yeah, my name is Richard Alls. I work for ULTra Global PRT in London. So we're going to go through the business case. Obviously, the guys have gone through some of the... Bear with me, I'll just get my webcam started. There we go. So some of the guys have gone through some of the benefits of automated transit networks, how they work, where they work. And what I wanted to do was to give you a bit of a flavour of some of the financial benefits of an ATN. How do they commercially work, and how can you monetize some of those benefits that Peter talked about at the start? So I've broken down some of the benefactors into three groups: land developers, transit operators, and the end users. So land developers, that could be the local government, that could be airport operators, that could be real estate people. There's the transit operators, whether that be public or private. And then there's the end users, the passengers, the people that actually use the system. So looking at the first column, we know that in transport, connectivity concentrically increases the value of land around different areas, whether that be business parks, around airports. And if you can utilize something like ATNs, which are flexible, relatively unobtrusive, relatively lightweight. And if you can integrate that into the spatial planning of a network, then really you can take advantage of increasing the value of that land. There's other advantages for land developers. Some of the sustainable and green sides of ATN networks. For instance, the networks used both at Heathrow and at Masdar, zero emission on site. In terms of the transit operators, you can increase the ridership of your network because you're providing a better service. There's more chance that you will achieve modal shift. And with some of the basic sides and aspects of ATN networks, there's lower maintenance, therefore there's lower operating costs. The higher availability of all the systems, again, reduce the operating costs. And the systems, all automated, offer a safer and lower energy consumption than some of the other modal products available. And finally, the most important people, the users. People tend to view public transport in terms of its value. Someone needs to get from point A to point B, and the value of that trip will determine if they will take the trip or not. And so if you can drive the value by offering a better service, then we think that you can increase the modal shift, you can increase the enjoyment of the passenger, and therefore you can increase the revenues associated. So we've got a small graph here talking about some of the different aspects of ATN networks if you compare them to transit and also cars. Clearly we're talking again about value, and if you can offer better value, more people are likely to use the system and you can offer a better service. Some of the ones that I'd like to pick out here are the fact that it's on demand, very important. If you can reduce waiting times at the start of a journey, passengers will travel to their destination earlier. If that's an airport, they may be in the departures lounge for 10 minutes more, dwell time is increased. It may be a shopping mall. There's lots of ways that you can monetize the increased time that people get from automated transit networks. It's private, it's safe and secure. One of the things that people perhaps dislike about public transport networks is that you're unable to have a private and secure travel. ATN networks use smaller vehicles, therefore offering people a more personalized destination and a more personalized travel from start to finish. And the last bit that I think Peter and Robert have both touched on is the fact that it's direct and non-stop. So I'll talk a little bit about PRT cost. No single application of PRT, GRT or ATNs is the same. And so this is slightly finger in the air. But this is a small model that we've drawn up at ULTra, and it talks about PRT cost in terms of the site conditions, the demand that needs to be served, and the location, the environment of the application. So to give you a brief example, the system at Heathrow is quite low capacity. We have 21 vehicles operating on a system that's 4 kilometers with 3 stations. So there's 5 vehicles per kilometer. Heathrow as an airport, as an area that we retrofitted the system, is a difficult installation environment. And so what we're looking at, if we look along the bottom, 5 is the first line that you see on the bottom axis. If we take that up, it's around 5 million pounds, British pounds, so I guess 8 or so million US dollars per kilometer. So please feel free to have a look at this model, ask any questions about it. It is very finger in the air, but it's a model that we like to use just to give a small brief summary of the cost of ATN networks, particularly PRT. And there are lots of revenue streams and savings associated with ATN, and some of them I can talk about in the context of Heathrow, and I'll just go down the left-hand column now. So in terms of sponsorship and advertising, it's something that's been utilised at the Heathrow system, but what I think we can realise from transport systems worldwide is that small innovative systems can actually offer a lot of value for sponsorship. For example, if we take the Emirates airline, which is a cable car in East London, the capital cost of that system was 60 million, and actually Emirates, the airline, have decided to pay 36 million British pounds to have the sponsorship for 10 years. So you can see that these small, innovative, zero emission, on-site, green, sustainable transport systems can offer real value in terms of sponsorship and advertising. At Heathrow, the system has been sponsored in the last year by the Marriott Hotel Group, and we believe that will continue for the next year. In terms of farebox, as I said, if you can achieve modal shift, you're attracting more people on because you're offering a better, more premium service, then actually you can increase the farebox. So there's revenue coming in from that. You can increase the rents and the service fees in land proximate to ATN networks. Again, looking at London for an example, but if your office is situated next to one of the tube stations, then actually you can attract almost double the rent of a property that's situated beyond walking distance. And so that's really what we want to try and achieve. We want to concentrically increase the value of land by bringing them closer to larger transit networks, solving that last mile connectivity issue. In terms of parking fees, you can increase the parking fees. People are generally happier to pay for a more premium service. At Heathrow, our system serves the business car park, and we actually increased prices by 20%, but actually 7% more people have come. It proves that automated transit networks, by improving the service, people are happier to pay for that more premium service. And third-party partnerships, like Robert referred to in some of the applications, if you can bring in third parties, maybe that's businesses, maybe that's local hotels on an airport campus, people will pay for improved connectivity. And that's something that's been experienced, I know at Heathrow, a local hotel, and now have access to the Heathrow system. And that's increased the value of that hotel, the room occupancy, and I think the hotel can now consider raising their room prices. But in terms of savings, there's many to be had. Lower capex, the systems are lightweight, they are very basic in terms of their infrastructure, and therefore they're low cost in terms of their building. And the same goes for OPEX. Automated networks, real-time information about vehicles, therefore you can check the health and the reliability of systems as they're traveling around, as they're carrying passengers, and you can minimize that disruption going forward. Increasing the staff productivity, if you can get staff in and out of your office quicker and generally happier because they haven't had to wait in the cold British weather, then generally they will be happier to work, they will do more work, and that's better for your business. No disruption to services. I'm not sure if anyone on the line is from the UK. We've got a great system being built, a tram network in Edinburgh, but actually it suffered over the last year because the disruptions to the services on the ground has been as such that it's driven people away from some of the main high street areas in Edinburgh. It's going to be a great system, but they've had to remove some of the services from under the ground. It's caused a lot of disruption. With lightweight systems that can be built off-site, prefabricated largely, and shipped in, put together very easily, you minimize that disruption. And you can reduce traffic. I know at Masdar there is no cars allowed on site, so you've reduced the need to run buses around the city. At Heathrow, we've removed 70,000 bus journeys from the perimeter roads each year, and that's resulted in the saving of 200 tons of CO2 each year, which may sound a bit silly coming from an airport, but Heathrow places a lot of emphasis on reducing its carbon emissions in terms of surface access, and an automated transit network, the Heathrow pod, has helped them to achieve that. So that's it from me. Thank you very much, and I look forward to answering your questions.
Right. Thank you, everybody. Very interesting. We have a few questions that we should go through. So let's start with Fred Payne's question, which I'll read out. And I think we'll see who's best suited to answer it. But if I just run through it first, Fred says ATN technology seems to be validated. How can one get valid estimates of ATN component costs for construction and operations? How can one get valid projections of probable ridership and income potential? If a business case of costs and income is validated, what is required for the project to be built? So quite a lot of questions there. So let's perhaps start with Peter. Peter, are you prepared to take that question? I'll pass you over.
David, I'm sorry, I was distracted. Could you repeat the question?
Yep, I'll have a go. Basically, to summarise Fred's question, it was to do with how can one get valid estimates of cost and valid projections of ridership and income potential. There was more to it than that, but that's a start. So I know it's something you guys are looking at, Peter.
Yeah, and it's Fred, this is something that I've persuaded the ATRA industry group to tackle, and we're developing a committee that includes suppliers to work up unit costs that can be publicly available, and so that we can get a better handle on what the costs of these systems are. One of the difficulties we have is that each vendor treats their unit costs as something that's proprietary, and so we're working around that to get more publicly available unit costs. In the past, costs have only been available more or less on a per mile or a per kilometer basis, which is not adequate when dealing with applications that tend to vary a great deal. So you might have a small application on an airport and a longer application like you have in a transit corridor, and then a bigger application somewhere else that's a widespread network, and these costs per mile just don't cut it. So ATRA is working on coming up with publicly available unit costs. So I hope that answers that part of your question. Of ridership, that is a key issue, and it can only really be got at through quite detailed analysis. We need to figure out where people want to go, when they want to go, and how many want to move, and then figure out which of those people the system could serve, and then figure out which of those people would want to use the system. So it's quite a complex analysis that needs to be undertaken. I'd welcome other people to jump in to answer this question too, because I've talked about it a lot.
Thank you,
And
Peter.
so let's have some other people have a go.
Thanks, Peter. That's a good start. Robert, did you want to contribute a little bit there, and then perhaps we'll move on to...
Yeah, I think what you end up with these type of systems at this stage of their development cycle, and with the degree of variables that are in the system, that you actually need the expertise of multiple parties to make a good assessment of an application. You'll need somebody with a local knowledge to contribute the local culture. What are people willing to do? What is the local sentiments? You'll need a consultant with good knowledge on forecasting ridership, people behavior, the willingness, what kind of money they're willing to pay for a journey. You'll need a public transport operator in that sense to contribute the knowledge about how to operate such system. You'll need a vendor to contribute the knowledge about what's the best way to configure the system in light of all those characteristics. And you'll need a preferably local infrastructure company to supply you the pricing on the infrastructure, because that can be very different in other parts of the world as well, depending on steel and concrete prices at that time. And if you really upfront want to hash all this out, the only way to do that is to go through a proper detailed study. As a vendor, I'll state that I was very happy to be involved and contributing information to consultants for various studies to make sure that they had all the information they could need to make the best assessment of an application.
Thank you, Robert. Perhaps moving on to a different question. We have one from Graham Hill here, and he says that Richard mentioned there is a certain size of passenger capability within ATN. Why is this defined, and why can't larger capacity coaches fall into this category? And I know another member who hasn't yet spoken of ATRA would like to contribute to this. That's Nathan Corrins. So, Nathan, do you want to?
Sure thing. So I answered this partially in the chat window, but thought I would elaborate on it a little bit. So the thing with personal rapid transit systems is that they're essentially analogous to automated taxis. And in that, they serve individual groups of passengers going directly from their origin to their destination. So it makes sense to have them sized similar to how you would size a taxi. Now, it does also make sense to have larger vehicles sometimes, and that's where the group rapid transit systems come in. So the group rapid transit systems are more like automated buses in that they are stopping at stations, sometimes on a schedule, sometimes on request, depending on the operating methodology of the system. And in that case, you have different groups of people sharing the vehicle. Now, one thing that people often wonder is, isn't it more efficient to have more people in a single vehicle? And the answer is sometimes yes, sometimes no. If you have a lot of people going from a single origin to a single destination, or a lot of people going along a single corridor, then it does make sense for people to share a vehicle because everybody is going in the same ways anyhow. When you're in a network configuration where you have many different places of origins and destinations, and you have a demand pattern which does not have a single corridor or a single focus, then it's very difficult to actually get groups of people to share vehicles in an efficient way. Either you need to send the vehicle on a circuitous path to pick people up, which is inefficient, or you need to run larger vehicles that are mostly empty, carrying only one or two passengers, and that's also inefficient. So so depending on the demand pattern, that's how you would size the vehicles for your system and how you would choose a personal rapid transit or group rapid transit. Hope that answers your question.
Thanks very much, Nathan. That was very interesting. I have another question, which I believe was, how long does it take before systems can serve or service passengers, which I think relates to perhaps the time it takes to construct. But I'll pass that over to Robert, who I know has a view. Robert?
Yes, thank you, David. Well, for any system, it greatly depends on the size of the system. The smaller the system is, the easier it is to realize, and the easier you make the system also is explained by, say, that your infrastructure is at grade instead of elevated. So I would say for a typical system, elevated a 2 to 3 year term to realization is typical. 2 years would be relatively quick. 3 years would be relatively long. So you're looking for a duration somewhere in between that time period.
Thanks, Robert. I'll just perhaps ask Richard the same question to see if we get a different view. Richard, are you available to comment on that? It was really just about...
That's no problem. I'd agree certainly with what Robert says. I think it's very important. The first part of any realizing any system is the simulation part of it. It's something that a lot of the people on the call today have capabilities in. The ability to maximize the efficiency of a system by taking in demand matrices, working out how many people are going to use a system at what times, really configure the system to suit the application. So I think that's a very important part, and that often takes maybe 6 months or so. As I said, there's capabilities within that group, within this group, to do that. And then I know that certainly at ULTra we look at systems because they're lightweight, because they're easy to construct, can be prefabricated off-site. with minimal disruption once they're built. We think certainly 2 years for construction is achievable, certainly.
Thanks, Richard. I think another point on that, it does also depend very much on the local approvals process as well. So in terms of construction, yeah, that's relatively easy to define, but the permitting and necessary approvals can be very dependent on local conditions and also the ability of the local authorities to recognize PRT or ATNs and apply the appropriate processes. Taking another question which I don't think we've answered. There's one here which is in terms of getting people out of cars and into shared vehicles in an ATN system. I think I'll just kick off, but then I'll pass it on. But in my view, I think certainly the impersonal rapid transit systems allows people to travel on their own or in their own groups, which is a big part of making the systems more attractive. They should be local to where you are, but also they can be tailored to your requirements. So in terms of if you have a frequent user card, which would be like an Oyster type card in London, then it can recognize your preferences in terms of lighting levels, temperature, perhaps even radio station or music, so that the system is going to know who you are, what those preferences are, and set the parameters to deliver that. So I think it can be quite a tailored experience. Is anyone else? Robert, I think you're always keen to answer. Robert, do you want to have a go at justifying why people might want to move from cars into?
Well, there's it really depends on the main characteristic. If people are traveling with public transportation, or people are traveling, public transportation is as weak as the weakest link in the chain of the different systems that people are using to get to their final destination. So when you install ATN and you improve the weakest link, it might just make public transportation a very valid alternative for car users. At the same time, if you have a link where there are multiple weak links and you just improve one of them, the chance that you actually get people to switch from their car to public transportation is much smaller, because they still have another link that's very unattractive for them to use. So when a study like this is done, it's very important to look at where are people coming from, what is their typical journey, and is the area that you're looking at actually the problematic part for a large degree of those people. Because if that's not the most problematic part, then you can improve public transportation locally, and you can increase the degree to which people can travel between buildings on or within a certain area. But what you're not getting is them switching from cars to public transportation, because it might be the link at their house towards the business park that's the worst area out of it. So it requires a very careful study of each application individually.
Thanks, Robert.
To address the question about procurement and where procurement is going on around the world, and this is something that's very difficult to know. Right now, I'm not aware of any actual procurement activities specifically related to ATN, but that doesn't mean that they're not going on. For example, the Coimbra system in Portugal actually went into service without anybody in the industry really being aware that it was happening. So these things sometimes go on and we don't know about them. So there probably is more activity than we're aware of. I do know there's a lot of activity around the world studying systems and getting ready to consider going to procurement. The other question related to procurement was who prepares the procurement documents, the plans and specifications and requirements, and that's something that's normally done by the owner that wants to buy the system, and they usually utilize consultants who specialize in the industry to prepare these documents. So hopefully that answers that question. Another question I'd like to address is the question related to what are the necessary attributes of ATN. And I guess, Carl, you want something specifically, not PRT or GRT. Well, the attributes of ATN are simply automated transit networks, and they cover the attributes and include the attributes of PRT and GRT. So ATN is driverless, the stations are offline, the systems are networked so that vehicles can go to any specific station in the network, typically bypassing all other stations, although stops may be made. ATN doesn't necessarily require direct non-stop travel. And people typically travel together in small groups, which may also include larger groups because ATN covers both PRT and GRT. So the short answer is ATN includes PRT and GRT. And another key element that enables the offline stations is onboard switching. ATN switching is typically not taking place on the guideway or on the rail. There's nothing that moves on the guideway. The switching is in the vehicle. Thank you.
Thank you, Peter. Just wondering if we have any more questions that we haven't covered. I'd perhaps just like to add something on the procurement side of things, having been responsible for procuring the system at Heathrow on behalf of the airport authority there. And at the time, 6-7 years ago, perhaps even a bit more than that now, we had to develop a methodology ourselves. But I think now there are a number of people, for instance, members of the ATRA industry group, that are able to supply advice depending on the local requirements. So it's, if you wanted to pose a more specific question to perhaps through the email on the site, then we can respond appropriately. Right, I'm just going to see if there are any more questions. Gents, I'll just open up the floor. Is there any other points that we'd like to cover? No? I think
Actually, if I could add one quick point on where to go for procurement advice. Right now, there is, it's a little bit disparate from country to country. There's an organization called ULTra, which has actually put together some advice on procurement here in the UK. I've just posted the link to that. And that could perhaps serve as a template for other regions, but right now there isn't really a unified system for that around the world.
All right, thank you. Thanks, Nathan. Just looking at the questions, there's one here about being interested in bringing ATN to the community. I don't think we've answered that one. I think perhaps engaging with ATRA Industry Group would be a start to learn more about the processes, starting to locate a potential site and just creating an interest, really. But any other views, gentlemen, around the webinar?
Yeah, I can actually contribute a little bit to that because I actually find it one of the most difficult questions to answer. If you're let's say a private individual and an interested citizen, it's kind of hard to get big wheels in motion. So to get a city or to get a developer on whose land you're living to move to consider these type of systems, it's a long process, and it means a lot of lobbying. So I think David is absolutely right that if you look at the organization that ATRA is within the industry group, we are, well, let's say we're the companies, but ATRA as the whole organization is open to anyone. So I would certainly encourage any individual that's interested in these type of systems to join ATRA, which is a, well, personal opinion, this ridiculously low fee for a yearly contribution, and you're able to get into all the discussions and all the interactions that ATRA does on a yearly basis, and perhaps find minds alike